दोस्तों, आज आपको सिस्टमेटिक अरेंजमेंट ऑफ स्टीम पावर स्टेशन के बारे में बताएंगे। दिस इज द कोल स्टोरेज, दिस इज द कोल हैंडलिंग प्लांट, दिस इज द एश स्टोरेज, this is the ash handling plant, this is the boiler, this is the super heater, this is the economizer, this is the air preheater, this is the forced draught fan, air preheater, this is the chimney, this is the induced draught fan, superheater, valve, turbine, steam turbine, coupling, alternator, exciter, transformer, isolator, circuit breaker, isolator, and bus bar RYB. This is the river, cooling water, condenser, circulating water pump, condensate extraction pump, feed water pump, water treatment chamber, feed water heater, and then this goes to economizer. This is the diagram of steam power station, and then this is diagram. The function of steam power station. Steam power station involves the convergence of heat of coal combustion into electrical energy. Yet it embraces many arrangements for proper working and efficiency. The systematic arrangement of modern steam power station is given as per diagram. The whole arrangement can be divided into following stages for the sake of simplicity. First is coal and ash handling arrangement. Second is steam generating stage plant. Third is steam turbine. Fourth is alternator. 5 is feed water. 6 is cooling arrangement. Then what is coal and ash handling plant? The coal is transported to the power station by road or rail and is stored in cold storage plant. Cold storage plant. Storage of coal is primarily a matter of protection against coal strikes, failure of transportation system, and general coal storage. From the coal storage plant, coal is delivered to the coal handling plant where it is pulverized. It means crushed into small pieces in order to increase its surface exposure, thus promoting rapid combustion without using large quantity of excess air. The pulverized coal is fed to the boiler by belt conveyors. The coal is burnt in the boiler and ash produced after the complete combustion of coal is removed to the ash handling plant and then delivered to the ash storage plant for disposal. The removal of ash from the boiler furnace is necessary for proper burning of coal. It is worthwhile to give a passing reference to the amount of coal burnt and ash produced in a modern thermal power station. A 100 megawatt station operating at 50%. A 100 megawatt station operating at 50% load factor may burn about 20,000 tons of coal per month, and ash produced may be to the tune of 10 to 15% of coal fires. It means 2,000 to 3,000 tons. In fact, is a thermal station about 50% to 60% of the total operating cost consists of fuel purchasing and its handling. Then, second, steam generating plant. Steam generating plant. The steam generating plant consists of a boiler for the production of steam and other auxiliary equipment for the utilization of flue gases. For the utilization of flue gases, boiler, the heat of combustion of a coal in the boiler is utilized to convert water into steam at high temperature and pressure. The flue gases from the boiler make their journey through superheater, economizer and air preheater and are finally exhausted to atmosphere through the chimney. Second, superheater. The steam produced in the boiler is wet and is passed through a superheater where it is dried and superheated. It means steam temperature increased above that of boiling point of the water by the flue gases on their way to chimney. Superheating provides two principal benefits. Firstly, the overall efficiency is increased. Secondly, too much condensation in the last stage of turbine, which would cause blade corrosion, is avoided. The superheated steam from the superheater is fed to steam turbine through the main valve. Economizer is essentially a feed water heater and derives heat from the flue gases for this purpose. The feed water is fed to the economizer before supplying to the boiler. The economizer extracts a part of heat of flue gases to increase the feed water temperature. Air preheater and air preheater increases the temperature of air supplied for coal burning by deriving heat from the flue gases. Air is drawn from the atmosphere by a forced draught fan and is passed through air preheater before supplying to the boiler furnace. The air preheater extracts heat from the flue gases and increases the temperature of air used for coal combustion. The principal benefits of preheating the air are increased thermal efficiency and increased steam capacity per square meter of boiler surface. Third, steam turbine. The dry and superheated steam. The dry and superheated steam from the superheater to feed to the steam turbine through main valve. The heat energy of steam when passing over the blade of turbine is converted into mechanical energy after giving heat energy to turbine. The steam is exhausted to the condenser, to the condenser, to the condenser, to the condenser, which condenses the exhausted steam by means of cold water circulation. Alternator. The steam turbine is coupled to an alternator. The alternator converts mechanical energy of turbine into electrical energy. The electrical output from the alternator is delivered to the bus bar. This is the bus bar. Delivered to the bus bar through transformer, circuit isolator, circuit breaker and isolator. Feed water. The condensate from the condenser is used as feed water to the boiler. Some water may be lost in the cycle, which is suitably made up from external source. The feed water on its way to the boiler is heated by water heater and economizer. This help is raising the overall efficiency of the plant. Cooling arrangement. In order to improve the efficiency of plant, the steam exhausted from the turbine is condensed by means of condenser. Water is drawn from the natural source of supply such as river, canal and lake and is circulated through the condenser. The circulating water take up the heat of exhausted steam and itself become hot. This hot water coming out from the condenser is discharged at a suitable location down the river. In the case of availability of water from the source of supply is not assured throughout the year, cooling turbines are used. Cooling turbine are used. Cooling turbine are used. Cooling turbine are used during the scarcity of water in the river. Hot water from condenser is passed onto the cooling tower where it is cooled. The cold water from the cooling tower is reused in the condenser. This is the function of working of the steam power station as per diagram which is derived to you. अगर आपको ये वीडियो अच्छा लगा तो आप जो है लाइक कीजिए। अगर ये वीडियो अच्छा नहीं लगा तो आप इसको डिसलाइक कीजिए और कमेंट में बताइए। कमेंट के माध्यम से आप हमको बताइए। दिस इज द डायग्राम ऑफ स्टीम पावर स्टेशन। स्टीम पावर स्टेशन। Thank you.